Okay, this will be our last video for section 3.1 for Introduction to Proofs. I just want to point out before I start the activity that the additional writing guides, all the writing guide stuff in this book, I really like. And I think you guys should make sure to actually read those to help you prepare for writing proofs. I'll be sharing with you, once we get really into writing proofs, I'll be sharing a rubric that I use for grading proofs. But right now, just know that that rubric fits pretty well with the writing guidelines from this textbook. So knowing your audience, use complete sentences and proper paragraph structure. Keep it simple. Drafts and revising are often very good, especially easy when you're typing them instead of writing them. It's a lot easier to edit your drafts when you're typing, that sort of thing. Okay, now we're going to turn in your book to activity 3.5 on page 84. So find several integers that are congruent to 5 modulo 6 and square each of these integers. Okay, so activity 3.5. Several integers congruent to 5 modulo 6. So 5 is congruent to 5 modulo 6, -1, 11, 3 is several, I don't know. For each integer, and then square each one. So then 25, 1, 121. Okay. For each integer, for number 2 says for each integer m, determine any integer what you observed. Okay. So for each integer m, determine an integer k. All right. So basically, an integer k between 0 and 6, including 0 but not including 6, such that m squared is equivalent to k mod 6. So for that one, it's 1. This is 1 more than 24. That's 1 more than 120. So this is 25 equals 24, which is 4 times 6 plus 1. 1 equals 0 times 6 plus 1. And 121 equals 120 is 20 times 6 plus 1. That's interesting. I observed that I always get plus 1. All right, number 3. Based on the work in part 2, complete the following conjecture. Let m be an integer. If m is equivalent to 5 mod 6, then m squared is equivalent to 1 mod 6. Okay, number 4. Complete a no-show table for the conjecture. All right, let's get started. So first, I've got my hypothesis. My hypothesis is basically that a sentence let m be an integer such that m is equivalent to 5 mod 6. Hopefully I gave myself enough space. M is equivalent to 5 mod 6. Barely enough space. That's my hypothesis. Okay, call that P. And then if I had a whiteboard, it'd be a little easier to know. I'll just sort of go to the very bottom here, and we'll probably not need the whole table. And so I want to show that m squared is equivalent to 1 mod 6. Okay, so let's start. What does it mean that m is equivalent to 5 mod 6? And m equals 6 times what integer do you want to use? Let's use a again. 6 times a plus 5 for some a in the integers. So that's definition. Okay? All right. Now, let's unpack the definition here. So what does it mean that m squared is equivalent to 1 mod 6? Well, that means that m squared equals 6 times b, 6b plus 1 for some b integers. Okay? That makes this one by definition. Okay? I have unpacked the definitions into equal signs. So I started with equivalent non-dual things. Now I have honest to goodness equal signs with honest to goodness integers. Okay? So then it's just algebra to go from here to there. Well, what should I do? I want an m squared here, so I should probably square the m. Well, m squared equals, now it's time to FOIL. I think I'll just leave it first. So that's substitution. Okay, now FOIL it. M squared equals 36 a squared. And then 6a times 5 is 30. 6a, so the middle two terms add up to 60a plus 25. That's algebra. Okay, now what do I want? I want a plus 1, not a plus 25. So take 1 off of that 25. Like you had a 25, I don't know, what do you have 25 things of? It was 25 students, and you said, all right, you are no longer part of the group. Now it's just 24, and then now and 1. Okay, so we'll do that. Say m squared equals 36 a squared plus 60a plus 24 plus 1. That's again, that's just algebra. Not even algebra, it's arithmetic, but we'll just call it algebra. All right, now that means that m squared equals, let's factor 6 out of everything we can. 6 times 6a plus 2a squared plus 10a plus 4 plus 1. Well, that's algebra. And then 6a squared plus 10a plus 4 is an integer. It's closure of the integers. And so then just letting b equal that thing. Squared plus 10a plus 4. All right, sorry that my handwriting got a little small there. Okay, that completes the activity.